Okay, so what is TempDB? We all know that's kind of temporary database. Of course, system database, but still it is a kind of temporary database. So everything that gets created inside the TempDB will eventually get wiped out if you restart the SQL instance or the SQL Server, right? So there are some improvements, few improvements from I should say from 2000 onwards, not just 2012 or something, because they started improving from 2000, 2005, 2014, 2016. So we have many versions from right from 2000 to 22, but there are certain improvements and enhancements that were made to TempDB. So I'd just like to discuss about them, and then I will show you a demo, how it happened, and the various scenarios that I will show you how to, the improvements that Microsoft has come up with on the latest version of 22 as well. So I have 4 machines. I just wanted to show you quickly. What is that? Sorry. So I have 4 machines, 14, 16, 19, and 22. So I'll show you a demo on all of these versions. Yeah, someone was about to ask something. So why TempDB? We all know it's a kind of temporary database where the transactions would get minimally logged, and the structure is same as the other user databases, but it recreates every time when we restart the instance, right? So what are the different things that get stored inside my TempDB? So we all know it's kind of like temporary tables, DBCC, CheckDB, table variables, cursors, triggers, statistics update, spools, whatnot, row store versioning. There are so many things that gets stored inside my TempDB. So I don't know how many of you heard this term. Brentozer is used to determine TempDB as public toilet. Means everyone will step in and will try to make use of my TempDB. So we all know how resource intensive TempDB is. So I just wanted to show you a few demos on TempDB and the enhancements. So I just wanted to go through that enhancements part, and then okay, let me step it down. So okay. So these are the enhancements, guys. So right from 2000, we have these enhancements. I read this article. I will share this PDF once we are done with the session. So this is how the enhancements were made. So from SQL Server 2000, we have the support of trace flag 1118. And from 2005, they have made some improvements with respect to temp table cachings, and they have introduced row store versioning and the table variable support. And 2014, we have the in-memory OLTP, and there were certain enhancements made with respect to TempDB as well. And from 2016, we don't need to add trace flags 1117 and 1118. By the way, many of you might have gone to interviews, then might have asked you about TempDB best practices. So what is 1117 and what is 1118? Can you mute yourself if you are not talking? If you wanted to answer, go ahead and you can answer it. So what is 1117 and what is 1118? Can you hear me, or did I lost?
No, yes, we are
No,
able
we're able to hear you.
So why I need 1117 and 1118 trace flags?
1117 is for distributing the load on the equally or all the files.
Okay.
1118 is like converting the instead of creating Excel, let's go and creating pubs.
Yeah. So 1118 and 1117, they both are very important trace flags when it comes to TempDB. 1118 is to avoid mixed SGAM contention. I would say XGAM contention, and 1117 to distribute the files in an proportionally fill algorithm so that it can make use of round robin stuff. So those are the 2 flags. But from 2016, you need not turn on these flags. It is there by default. So from 2016, we have this 1117 and 1118 by default. And on 2017, again, they have come up something about PFS. I will show you with demos, but I just wanted to scroll it down so that I can show you a nice demo on this topic. So, okay, so these are all the improvements. So let's go to demo first, because I'm more interested in demos rather than talking theoretically. So I have 3 missions, as I told you. Okay, so this is my 2019. These are the screenshots so that you can easily find it. 2019 and 2022 and 2014. I opened up 3 missions. Okay, so I have generated few loads here. So this is a kind of query stress. Most of you might have known this tool. So I've made use of some query stress and O stress to generate the workload. So there are 3 important pages when it comes to TempDB, guys. This is very, very important. One is PFS page. So when you see contention like this, 2:1:1 means TempDB ID, database ID is 2. This is my file ID and this is my page number, right? So page number 1 stands for PFS and page number 2 stands for GAM and page number 3 stands for SGAM. So these are the page IDs. So if you are seeing contention on 2:1:1, it means it is PFS contention. And if you are seeing contention on 2:1:2, then it is GAM contention. And if it is 2:1:3, then it is SGAM contention. So my question is now, on the latest versions of SQL from 2016, since we need not turn on the trace flags, are we observing any SGAM contention on your systems? Are you seeing any SGAM contentions on your systems? SGAM is mixed allocation. I mean, mixed extents allocation. So whenever you are allocating an object, there are 2 ways to allocate an object: uniform extents and mixed extents, right? So SQL will allocate an extent for that object. And if it is mixed extent, you will get pages. I mean, it's like another object can make use of those same extents because extent is combination of 8 pages, whereas uniform extent has to be made use by single object. So this is the theory about GAM and SGAM. And PFS is for tracking the pages. PFS stands for page free space. So on your systems, on the latest version, are you observing any SGAM contention? Just a question. I would like to know. That's it. Nothing great here. Just wanted to know. Okay. So I don't know if you are seeing that
No.
contention or not. And we have 2 types of contention. I would say 3. Here they are calling it as 3 contentions, 3 different types of contentions. But basically, I've seen 2 types of contentions. So one is object allocation contention, and the other one is system table metadata contention. Okay, I will explain you properly. Let's me jump into demo, and we'll see in action. Sorry. Okay, let's jump in, and I'm trying to run a workload here. Okay, so this is my workload. Some query stress I'm using. I'm running the same workload and I have the same configuration. Oh, sorry, I'm getting a lot of noise. I'm running the same workload on all the 3 missions, means 2014, 2019, and 2022, parallelly on all the 4 missions. That's 3 missions. Okay, so since I'm running the load, let me make use of SP who is active, or else we can make use of our DMVs, sys DM exec request and all. So I'm checking where my contention is. You can see here, right? So all my contention is showing it as page latch. It's not page IO latch. There is a difference between page IO latch and page latch. Page latch means it's memory related contention. Page IO latch means it's disk level contention. So as of now, what we are observing is a page latch contention on PFS pages. I'm saying it as PFS pages because if you see this number, it is showing as 2:1:40440, right? So if you just calculate it, 40440 divided by 8088, so it is number 5, right? So every page, whatever the pages what you are seeing, for a PFS pages starts at page number 1, and the next PFS page inside our file is 8088. The next one is 16,000. Next one is 24, 32, 40, something like this. So we are observing PFS contention on 2014 system when I'm running that workload on the PFS. It's on PFS pages. It's not on GAM or SGAM. It's happening right now on PFS pages. Any questions here? Are you getting my point? Hello?
Yes, Vamsi.
Okay, so again, I'm running the same workload on 2014. If you see here, my batch requests, they are around 70, 72, somewhere around that. And if you see here, page latch waits. So waits are happening very frequently, and these are the waits started per second. So we are having huge number of waits happening on page latch. Page latch underscore up stands for update log. So we have the contention on our 2014 systems on PFS pages. So this query helps us to determine what are the pages. But I'm running the same load on 2019 and 2022 also. Okay, so I'm just starting this, and if you see, by the way, if you are on 2019, guys, you can make use of these two functions. Okay, this is one function and this is one DMV, which has been introduced from 2019. Okay, so this helps us to determine whether it is GAM page or SGAM page or PFS page or some other page. So system object page, everything can be determined with the help of these two functions. So one is this is one is function page risk tracker, and the other one is page info. These are available only on 2019. Okay, not before 2019. So it is from 2019. So as you can see, even here I have the contention, but the contention, whatever what we are seeing, is on GAM page, not on PFS page. Are you getting the point? The same workload, same number of CPU, same RAM, nothing. It's almost same. Not almost same. Everything is same. Okay, I will show you my 4 missions. If you see here, 2014, 2016, 2019, 2022, all are running with the same sizes, E4, BDS, V5 versions. And I have the same amount of RAM, 32 GB, I believe. And I have 4 CPUs. So they have the similar load, 4 processors, 32 GB, no changes. They look exactly same. And even the other settings, max top, COP, cast threshold for parallelism, all other settings are one at the same. But on 2019, we are observing contention on GAM pages. You can see it, right? Okay, let me run the workload again. Oh, this is on 2022. Sorry, let me step into 2019. So you are seeing contention on GAM pages, but not on PFS pages. But on 2014, the same workload is causing us PFS pages contention. Okay, so let me run this again. So if you see now it is back to 2:1:1. 2:1:1 stands for PFS pages contention. So on 2014, it is on PFS pages. On 2019, it is on GAM pages. Okay. And now I'm coming to 2022 and I'm running the same workload. It's happening now. So if you see, I don't see any wait types happening on 2022. Even the PFS contention is not there and GAM contention is also not there. Nothing is happening on 2022. My queries are running and we don't have any contention. So what is the change what Microsoft has come up with 2022, and what is the change Microsoft has come up on 2019, and what is not there on previous versions? That is what I intended to show. So any questions till now? Did you get the demo? Understood it?
Yes, Vamsi.
So what is PFS contention now? So PFS contention is happening only on uh, versions lesser than 2019. It's not happening from 2019. First thing, from 2019, even though I have avoided PFS contention, I still have contention with GAM. So my question is, we have only PFS and GAM contention, right? We are not observing SGAM here, basically because from 2016, 1118 flag is being turned on, and you will never see. I will not say never see. You will say it very rarely. SGAM contention will be there, but it will be very rare because SGAM pages needs to track of IAM pages. In case of in those scenarios, SGAM contention will come into picture, but you will see it very rarely from 2016. Okay, so now we have 3 types of contentions: PFS, GAM, SGAM. SGAM, as I told you, it will not happen from 2016. GAM is happening only on 2019. The same workload. I'm talking about workload here, and there is no contention at all on 2022. I am not seeing GAM or SGAM or PFS on 2022. Whereas on 2014, I'm seeing PFS contention. So why it is happening only on previous versions? Why not on 2019 or 2022? Of course, 2019 it's not the PFS, it's GAM contention. So let me explain you the improvements what they have made. Okay. So if you have any questions, let me know, guys. Otherwise, I could have just recorded this and uploaded onto YouTube. I just want session to be a bit interactive. That's the reason. Just give me a second. I think, yeah, this one. Okay. So this is the article what they have written, and this is about, as you can see, one page. Page number 1 is PFS, second page is GAM, third page is SGAM. As I told you, 8088. After these many pages, we will again see 8088 page is popping up for PFS. Okay. So now what the enhancement, what they have made on 2019, in 2019 and 2022, that's what we should see. Okay, so the contention, whatever I have shown you till now is related to object allocation contention. Means when you are trying to allocate an object or destroying an object, means create temp table or create table variable, whatever it is, or destroying means dropping the tables. In these scenarios, object allocation contention will come into picture. Okay, and on 2019, what they did is, let me go to this article. Okay, and to show you something. So this is how it works. Okay, so in the previous versions, whenever the algorithm works like this will try to grab an exclusive lock. It will try to grab an exclusive lock, page last exclusive, and it will scan for the rows. And if no rows are found, then um, it will release the lock. Otherwise, it will hold the lock until operation gets completed. Whereas on the newer versions, what they did is, instead of grabbing the exclusive lock, they are grabbing the shared locks. So since shared locks are compatible, many concurrent sessions can perform their actions. So that is the difference between exclusive lock and share lock. I know many of you guys know the difference between share lock and exclusive lock. The main difference is, in the older versions, I'm giving you a reason also. It's not just bluntly 2019 they have made some improvement. You have to understand what is that reason and why it is working properly on 2019 and 2022. Because they made a change. They made a change in respect to the way algorithms are getting processed. Okay, in the older versions, whenever we are working on TempDB, internally SQL Server is trying to grab an page latch exclusive lock. So exclusive locks will not allow any other locks. They are incompatible with any other locks, so you cannot hold any other lock. So you have to wait for that lock to get released. Whereas on the new algorithms from 2019, instead of exclusive lock, they are grabbing shared locks. Because shared locks are compatible with other locks, at least other shared locks, many sessions can update concurrently. Okay, so 2019, as you can see in my demo, that on 2019 we are not getting PFS page contention, but we are getting only GAM page contention. They avoided the PFS contention because a concurrent updates to the PFS pages started happening from 2019. Okay, means this algorithm has come into picture from 2019. So instead of having single exclusive lock, now I can take share lock, and many sessions can take share lock at a time. So that is nothing but concurrent PFS updates. So that is the improvement what they have made with respect to object allocation contention on 2019. Okay, again I'm repeating, on 2019 when it comes to object allocation contention, okay, we are not seeing PFS page contention. We are seeing only GAM contention because on 2019 Microsoft has changed the algorithm and now it can make use of concurrent PFS updates. That's why we are not seeing PFS allocation contention on 2019. Getting or not? I don't know. I'm just passing my information. So if you have any questions, let me know. Okay. So on 2022, we are not seeing any kind of contention, right? When I ran this workload, a little bit contention, but it's very rare. So if you see, it's not giving much. So yes, I got GAM contention, but it is very negligible, because when I run the same thing on 2019, you will see this contention throughout my workload. So you will see if I start this workload, the contention will remain the same throughout my workload. Sorry. So on 2022, what they have done is, on 2019 they made concurrent PFS updates, and now on 2022 they made concurrent GAM and SGAM updates as well. So that is the new improvement what they have made on 2022. Okay, so this is what he's saying. In SQL Server 2022, we have addressed the final common areas of contention by introducing concurrent GAM and SGAM updates similar to concurrent PFS updates. So these concurrent PFS updates started from 2019. Of course, if you apply any cumulative updates or something like that, you will see these enhancements even on 2017 and 2016 as well. But this product initially they launched this on 2019. Okay, so concurrent PFS updates are there on 2019, and on 2022 even they made a further improvement. Now we are getting concurrent GAM and SGAM updates. That is the improvement what they made in 2022. If someone goes to the interview, okay, if you can say like all the improvements what they have made right from the older versions to the newer version, it will be literally too good for the interviewer, right? Agreed? Okay, I don't know why people,
Yeah.
I know it's late night in India, so I can understand that. Okay, now we have another type of contention called as metadata contention. Metadata is nothing but, it's about data about data. Metadata is nothing but data about data, right? So if you see here, for every system table, for every database, we have some system tables. So for example, I opened up AdventureWorks 2019, and if you see, I have some system tables. Of course, let me open Tempdb because we are dealing with Tempdb. So this, why I'm not seeing any system table? We know that, right? Sys.objects, sys.objects, sys row, some system tables will be there inside every database, right? So that information is there. That contention, any contention on system tables is called as metadata contention. Let me check on older versions. I think it should be there. I don't know why we are not able to see system tables. Okay, I think we have to connect with DAC, I believe, to observe that system tables, but I will show you a demo. It will help you to understand what is metadata contention. So in your real time, if you are seeing contention on 2:1:1 or 2:1:2 or 2:1:3, it is object allocation contention. Okay. And if you are seeing something else apart from 2:1 some other number, then it is metadata contention. So there are two types of contentions inside my Tempdb. One is metadata contention. The other one is object allocation contention. The demo what I have shown till now is related to object allocation contention. Now I'll show you a demo on metadata contention. So let me get my workload. Okay, now the workload has started. Now if you see, it is now showing some other number, 2:1:16. Of course, this is GAM and PFS, but you are seeing the other numbers, right? 2:1:16. These numbers were not identified in my previous workload, but now you are seeing that some other numbers are appearing. So this is nothing but metadata contention. So I think the better example is here. So let me show you that part. Stress PowerShell, it's running. I'll stop this because stress cannot have two workloads at the same time. So that is the problem. I think I'm running this one. I'm not stopping the other. Okay. Okay. Now the workload is happening. And now if you see 2:1:120, 2:1:118, some other pages. So all these contention is tied up with metadata contention. Okay. I will show you on 2019 and 2022 so that you can identify that pages properly. So let me show you this. It's running now. If you see now, so this is data page. It's not GAM page or SGAM page. This is data page. And if you see, these are all the metadata objects. So this is the object name, sys SSCH objects. So now the contention is on metadata at metadata level. So my workload is done. It's simple workload. So if I run this again, you will see that happening. And now let me get the Puffman also. It's done already. Okay, and let me show you. So now if you see a batch request are somewhere around 300, right? Somewhere with 300 as my batch request. And the workload, once the workload gets done, it will come back to 0. So let me just run this workload again for a second. And this is, oh, sorry, not this one, cancel. So this so see this is again at the metadata level. So all this information, whatever what you are seeing is related to metadata contention. So this is on index page for this object, sys schema objects. So this is for metadata objects. Okay, let me show this on 2022. No audio, is it so?
No,
Oh, we can hear you clearly.
Okay, I got shocked to hear this. uh, Let me run this on 2022. And even on 2022 it will happen. See, so metadata contention is there even on 2022 unless if you turn on some settings. I'll show you what is that setting. Okay, and there is one script from Medera Solutions. It's a nice script. I will show you that also. There is that Tempdb scripts, Tempdb contention. Yeah, this one. Okay, this will help us to determine what is the real cost, and it's very nice and useful, but you can get this only from 2019 because as I said, those two functions, I mean one DMB and one function has been introduced from 2019. Let me show you this. So this is my script. As of now, nothing is happening. So if I introduce the workload, you will see that. So if you see, this is contention type is metadata contention. So he has written properly. So it will help us to understand much more clearly. Let me increase the number of threads so it will last for longer duration. So number of threads, I will say 50. You will see only certain with certain workloads, not with all kind of workloads. For the moment, I am not seeing that. But if you see the number of batch requests, as of now, it is 300, 320, right? So we can, okay, the workload is done. Let me see this now. Yeah, so see this metadata contention. So it happens on 2019 as well as on 2022. So to avoid metadata contention, we have this setting. So you have to turn on that setting. It requires a restart. Where is that? Mm. Mhm. I think this one. Okay, this is what from 2019 we have something called as memory optimized TempDB. Okay, what they have done is instead of keeping the metadata information on the disk, they made it into in-memory concept. They made use of in-memory and they kept all these what is that system objects into they made it into memory optimized tables. Instead of having them on disk, they converted them into memory optimized tables. Once you set this setting on, all the system objects will get converted into in-memory tables so that it will be faster. I don't know how many of you are okay with in-memory. In-memory is nothing but it will be there in memory, and also this requires a restart. You know why? Because it has to act on DLLs. Certain DLLs needs to be executed when you are changing the tables from the disk to in-memory. So that's the reason it requires a restart. So once I kept this setting on, once I turn this on, you will never see that contention. Metadata contention will not be there. That is the reason. I'm explaining you the reason, guys. So let me turn it on 2019 and 2022 and see how it works. So this is on 2019. and this is for 2022. Okay, and it requires a restart. Unfortunately, there is no other go. We have to perform that. 2019. But if you carry that workload on 2014, you cannot avoid it because there is no such option. I mean, not just on 2014, even up to 2017. Of course, I have seen a few CUs helping them to overcome that metadata contention, but I need to double check that part. Okay, I need to restart it now, right? Okay, so let me go to 2022 and see if I run that same example again. I'll increase the threads so that it will last for longer duration. I will say 50. Now it is getting started. And if you see the batch requests are somewhere around 284. And now if you see, are you observing any page latch waits now? It's absolutely zero. It's not happening at all. And even if I go to this query, I think the workload is done. Oh, it's still running. Now if I check this, there is no metadata contention at all. See, I'm running this multiple times. It's not at all happening. Okay, and I will run the workload again just to show you. See, there is no contention with respect to metadata. And even if you see the page latch waits, it's zero, means no contention at all. That is the improvement what they have made on 2019 with respect to metadata table. I mean, system tables. It's called as metadata contention. Once you turn this property on, you will never observe any contention with metadata. The same thing happens even on 2019. So I just restart it now. And if I show you, as of now, it is zero. And if I start the workload, usually this goes up a lot. But now, since I turn it on, it should not happen. Okay, see, zero, absolutely zero, no contention at all, no page latch waits, nothing. And even if I run this query, no. So this is the beauty of 2019. And if you're on 2022, you can enjoy concurrent GAM updates and SGAM updates as well. So that is different contention, that is object allocation contention. And this is about metadata table contention. So these are the two different types of contentions, and that's how we avoided the contention from older versions to newer versions. And by the way, just to let you know, guys, I'm using only one file. I'm not even following the best practices. If you see this, I don't have multiple files. I'm not allocated multiple files. I have 4 CPUs. I have to come up with 4 files for my TempDB, but I'm not doing that. Even though I have not done that, my workload is performing well as expected. Okay, so that is the beauty on 2022 and 2019. But on the older versions, definitely you need multiple files. But there is a statement that is coming up from Microsoft, but we have to wait, where they are saying from 2022, there is no need for you to turn on, to add multiple files. That is the statement. Because why that statement has come up, it's purely because of this algorithm change what they have made. Because they are using page latch shared lock instead of page latch exclusive. So concurrent PFS updates, concurrent GAM updates, concurrent SGAM updates are happening within a single file. You don't need to have multiple files. But again, they said they have to gather the data, and maybe down the line, there is a requirement where you need not add multiple data files for our TempDB. It's not yet proved. They are in the process. So it might happen. It's not a statement from me. It's from Microsoft. Okay, any questions? So have you observed all these different types of contention like object allocation or metadata contention, how to resolve those things?
No, Vamsi.
Not yet. No, Vamsi.
No,
Okay. So even for your information sake, guys, so multiple times our TempDB would get blown away, right? Like it will get full very fastly
Mm.
all of a sudden. So I've seen many people asking me, what are the statements that contributed to the TempDB growth? How will you find out that? If it is happening now, you can use you can make use of SP who is active, or these queries, or whatever the DM is, it's fine. But it happened already, and someone is asking you to investigate what are the statements, or how it happened, how the MDB has grown drastically all of a sudden. So if someone is asking for you for that kind of information, what are the things that you will do in real time? You will run free proc cache. I know there are many answers. They will say, just go and run free proc cache or restart the instance. That is fine. For alleviate the problem, you are running all those things. That is a different story. I don't want to talk about that. I just wanted to know, my TMDB has grown very fastly, and it has eaten up my entire disk. And how will you know that what are the statements that contributed for this growth?
We can check external events on TempDB group. There we can see the
So
SQL
uh,
query.
remember guys, unless you go with any configuration, like you have to run some kind of trace extend events, you said, right? So you
Yeah.
have to make use of a trace. I mean, if I go here, extend events, under extend events, by default I don't have anything. I have only system health and always on health session. So
Okay.
unless you go with some other session, so this remains same even on 2022. Let me go to 2022. I have not seen what is inside my 2022 management extend events. I think it will remain same. Okay, they just added telemetry, so there's no change at all with respect to 2022 as well. So you have to run certain kind of trace to capture that. But apart from that, is there any other solution?
I think we can have DMS to monitor the
Okay,
temperature.
my story is you went for lunch. Okay, you went for smoke. Okay, during that 15 minutes or 30 minutes, TempDB has grown drastically. And once you are back, it is not showing anything. So if you run SP who is active, it is nothing, no active queries at all. But TempDB has grown from 50 GB to some, say for example, 200 GB. So how will you know what happened during that half an hour or 45 minutes break, what you took? That is my question.
I mean, we can use the query store, right? See, just to monitor
Uh,
the
So
memory
my
use.
best solution is, so I have some few queries. Of course, it is there on internet. I don't know how many of you are making use of that. So if you can track those queries, like I usually what I do is I will run that job for every 1 minute. So it captures the statement and it captures everything, like what are the statements that contributed to the growth. And we can know because we have different types, right? We have row versioning or what is that? TempDB creation, cursors, all these things. So there are so many things that make use of TempDB. So we don't know what is that growth that has contributed for the TempDB. So I will run that job for every 1 minute and I capture those statements. And if someone asks me, I can straight away say, okay, this statement has contributed to this much growth. I have not created that demo. I have that, but I sorry, I didn't create that today in today's class. But maybe in later sessions, I will show you how to track the TempDB queries, and if something goes wrong, how to prove that these are the statements that are, I mean, the culprit statements. Okay, so that's it from my side, guys. So if you have any questions, let me know. So that is those are all the improvements what they made. So if you are going for interviews or if you wanted to take advantages of the new versions, please be well versed so that you can confidently talk to your client saying that this is the improvement. Now you can say on 2022, we have concurrent PFS updates, concurrent SGAM updates and SGAM updates. Whereas on 2019, we have only concurrent PFS updates. Okay, there is no concurrent GAM and SGAM. And older versions, of course, there is no such concepts. And when it comes to metadata contention, we have only this from 2019. I read somewhere that if you apply some CU 17 or something like that, you will avoid that contention also on 20 for older versions. I am talking about metadata contention. So I'm not sure about that. I need to check the versions, but this is how you should talk to your clients, saying that, okay, these are the advantages if I go to the latest versions. We can make use of that. Okay, so I'm wrapping up. If you have any questions, let me know. I will try to take some sessions, not majorly on 2022, because I wanted to explore 2022 a lot. There are few enhancements which made me to go crazy with 2022. So I will take few more sessions, but this is just on TempDB. Any questions or else I will stop. Okay, so I will upload this onto YouTube. You can watch over there. So can you share the link and the PDF file? PDF file is this one. Link for what link? I don't know what is that link.
Maybe this one.
Okay, this concurrent things. Okay. Just say, just search for SQL Server 2022 updates on Tempdb. You will get this link. This is the first link, and I will share this PDF growth history. Yeah, I will. Actually, I should have shown that, but no time. I came up very fast. Okay, guys. Thanks for your time, and catch you later.
Yeah, Vamsi, can you stay 1 minute back?
Okay.
Yeah.
Go ahead.
No, this is regarding your classes. I want to discuss with you.
Oh, okay. So then I will stop the screen sharing. We can talk then. I'll stop the recording first.
No, I would like